Myself, Avinash Jail, Assistant Professor, Department of Electronics and Communication Engineering, SVC, Bangalore. Today, we will discuss about operation of NMOS transistor. Okay, so in the last class, we were discussing about the construction of NMOS transistor. So today class will start with the NMOS operation. So you can see the diagram here in the NMOS. The source as well as the drain region will be N plus. That means what? After using the N substrate, okay, so we are doping it and making it as a N plus. That is what highly doped N type semiconductor. We say it as a N plus. That means what? It is having the valence electrons. Okay. So the substrate, the body is of P type, and between the body as well as gate, there is a silicon dioxide. There is a silicon dioxide. So here the body is usually tied to the ground, that is 0 volts. So out of 4 terminal, the body is tied to ground. That means what, one terminal is already connected to the ground. So now, depending on the gate voltage, the operation of NMOS will be understood. So here you can see that when the gate is at low voltage, what happens? The P-type body is at low voltage, fine, because we are giving the gate voltage 0. So body will also be already connected to the 0 voltage. It will be at 0 voltage. The source body and drain body diodes are off. That means what? When the voltage is not given, source to body connection and drain to body connections, those diodes are off. So why it is diodes are off? You can understand one thing. When we say something as a diode, okay, so it should be having a junction. So you can see that there is a junction between N plus region and as well as a P region. So P is for body and N plus is for source as well as N plus is for drain also. So that particular diodes are going to be off. So the no current is going to flow. So once the no current is going to flow, the transistor is considered to be off. Transistor is off. So I can say that for NMOS, if you give 0 to the gate voltage, the output is 0. Clear? So input is 0, output is also 0 because there is no current flow which is going to be taken place. That's the thing, first. So now we need to understand that when the gate voltage when we give the gate voltage and the gate voltage is at higher level. Okay, so you can see the diagram. You can see the same diagram where to the gate terminal we are giving the input as 1. So as we all know that, okay, so the input is a matter. Okay, so here 0 means 0 voltage, input 1 means we are going to give it as a 5 volts. So technically speaking, above 2.5 or 3 voltage threshold, we consider that particular input voltage as 1, that value as 1, binary value as 1. So now that is what exactly has been displayed in the diagram also. So the first diagram on the left side, I can see that the same diagram, like construction only, but we are given the gate voltage as 1. Okay, P type, the body is grounded. Okay, so in the right side, you can see that there is a source and there is a drain, and in between source and drain, there is a gate. In the gate, the 1 is been given. In the gate, the input voltage 1 has been given. Here, when the gate is at high voltage, okay, when the gate is at high voltage, the positive charge on the gate of the MOS capacitor. So what will happen when the gate voltage is being given? There is a positive charge which is on the gate of the MOS capacitor. See, MOS capacitor, how the MOS capacitor will happen? Between the gate and the body, there is silicon dioxide. So silicon dioxide as acting as a cavity. So on the either side, one is body and another one is what polysilicon will act as an insulator. So that particular metallic body and between the SiO2, so this particular thing you can consider as a capacitor structure. So in that positive charge on the gate of the mass capacitor, that is going to happen, and negative charge attracted to the body will going to happen. So obviously what will happen when the voltage is being given, positive charge is there in the gate region. Okay, so obviously when the gate is becoming positive, all the negative charges which are in the source as well as the drain, they're trying to move towards the gate, and that particular negative charges will get attracted to the positive charge. So this particular negative charge attract to the body. Okay, so it will invert a channel under the gate to the n type. So it will invert a channel under the gate to n type. Now current can flow through n type silicon from the source through the channel to the drain. So now what will happen? So whatever the electrons which are there, okay, so which are there in the source, that particular source will be transferred, which will pass through the body, which is of P type, and it will reach the drain. So when the electrons are reaching from source to drain, that means what current is flowing. Correct. Now the current can flow through the N type silicon from the source through the channel to the drain, and transistor is set to be on. Okay, so transistor is set to be on. I can say that when you give 1 to the NMOS, the output is 1. When you give 0, the output is 0. When you give 1, output is 1. That is what operation of NMOS transistor. Okay, so that is what exactly the thing which is going to happen. So I can see this particular diagram. Okay, after that, we'll go to the understanding of PMOS transistor. Okay, so here the construction wise, everything other things are very similar with respect to the NMOS and as well as the PMOS. Only thing is what in the PMOS transistor, so instead of N plus, okay, so the in the source as well as the drain, we are going to use the P plus semiconductor, and in the body we are going to use the N type. Okay, that particular interchanging is going to happen since the P plus is there in the source and drain, we call it as a PMOS transistor. Okay, so similar, but doping and voltages are reversed. So the body ties to high voltage, that is VDD. So when the body is tied to, okay, so when the body is tied to high voltage VDD, that means what here in the NMOS transistor, the body is connected to the ground, because it is also acting as a one terminal. We are connected into the ground, but in this PMOS transistor, we need to give the body to the high voltage. That is a reverse way. So now in the NMOS, if you give 0, output was 0. But here, when the NMOS, when the what you call for that for the PMOS, when you give the low voltage for the gate, okay, transistor will get turn on. So why it is so? Why? Because the gate will be called as what? Negative. So low voltage means what? Negative. So when the negative voltage is there, obviously the P plus things will get attracted towards the gate. Okay, so they will make the passage and they will pass through the source. They will pass through the body, which is of N type, from the source to the drain. So that means what? The charge carriers are passing. That means what? Definitely current will going to flow. Okay, that is what exactly the reason. That is what exactly the reason. So now when you give the gate as high voltage, what will happen? When you give the gate as high voltage, that means what? Gate is positive. When the positive is given, obviously positive repels each other. When the positive repels each other, definitely there will be no movement of charge carriers from the source to drain. So in that case, the transistor is set to be off. In that particular case, I can clearly say that the transistor is set to be off. So now, if I give the 0 to the PMOS transistor, output is 1. If I give 1 to the PMOS transistor, output is 0. That means what? It is exactly behaving like a inverter. It is exactly behaving like a inverter. When it is exactly behaving like an inverter, I can say that it is having the inverter behavior. Inverter behavior it is going to follow. It's a clear tube. So now we can see that polysilicon is there in the top, and same SiO2 is at middle, and other regions are there at the body is at the bottom. The same thing. The symbol, when you see that symbol, okay, so you can see the symbol, okay, so the transistor symbol between the source and drain, the gate symbol, you can see the bubble is there. That bubble indicates the inverted behavior. The bubble indicates inverted behavior of the PMOS transistor. So now we can see that the ground indicates power supply voltages when you're talking about. So the ground indicates 0 volts. So in 1980s onwards, okay, VDD means 5 volts. So, but when the modern processors are coming to existence, VDD has decreased in modern processors. So how it is high means high VDD would damage the modern tiny transistors. That is why they are going for low level VDD. So lower VDD, which also saves power also, and the damages which are going to happen to the tiny transistor. There are two advantages when you are decreasing the power. That is why I can say that one is what to damage the tiny transistor, and we can say the power also. So now what is the conclusion? Conclusion is very simple. VDD will be in the form of 3.3, 2.5, 1.8, 1.5, 1.2, 1.0, and so on. Now it is going on because 0 means 0 only. So 0 means 0 voltage. That means what is a ground only. So the value is also 0. But when I'm talking about VDD, in the 1980s it was 5 volts. Now it has been reduced to 3.3. Now it is 2.5, 1.8, 1.5, 1.2, 1.0 also it is coming to down. Okay, so the simple way I can understand that operation here, you can see the transistor as a switches. We can use MOS transistors as electrically controlled switches. So voltage at gate control path from the source to drain. So you can see that when the gate equal to for the NMOS in the first line, you can see that when the gate equal to 0, the diode will be off. The transistor will be off. When the gate equal to 1, the transistor is on. Similarly, that means what it is like acting as a gate. Okay, when the gate is not closed, there is no movement of electric charge carriers. When there is no movement of electric charge carrier, that means what there is no flow of current electricity. The PMOS also, the gate is 0 means it is going to on, and gate equal to 1 means it is going to off. That is what exactly is explained in this particular diagram. You can able to see. Okay, so thank you for listening.